Your first question asks which model best represents the answer to this problem. You have 3/10 plus 1 and 5/10. Let's look at 1 and 5/10 real quick for just a minute. What does 1 and 5/10 mean? What's that telling us, Ainsley?
There's one whole and 5/10.
Yeah, there's one whole and there's 5/10 of another one. And what are we adding to that 5/10 of another one?
3/10.
We're adding 3/10 more. So if I combine my fractions, 3/10 plus 5/10, how many tenths do I have, Tommy?
8.
Yeah, we've got 8/10. And we still have that one whole shaded in too, don't we? From 1 and 5/10. So 3/10 plus 1 and 5/10 equals 1 and 8/10. Which option has 1 and 8/10 shaded in, Callie?
Number 1.
Option 1 is correct. I want you to take a look at something really quickly, though. Look at option 3. Does option 3 have the same amount shaded?
Yes.
Why is option 3? Yeah, it's showing some being crossed out. Same thing with option number 4. It's showing one whole is being crossed out. So the correct answer is option 1. That's the only one where it's only shaded, not taken away.
Well, number 2 and taken away is just not good.
Right, it just doesn't have the correct amount. You're right. All right. Let's look at number 2. All right, number 2 asks which angle is 180 degrees? What angle is 180 degrees? Graceland?
Option 2.
How do you know option 2 is 180 degrees?
Because each line on the circle is 90.
Yeah,
And 90 plus 90 is 180.
exactly. Each one of these sections represents a 90-degree angle. We can see it forms a perfect corner, perfect 90-degree angle, and 90 plus 90 equals 180. So from here around to this line is a 90-degree angle, and from the line back to here is another 90 degrees. 90 plus 90 is 180. So option 2 is correct. All right, let's look at number 3. We're identifying the type of triangle. Remember, we're going to classify the triangle by the sides and by the angles. So let's look at the angles first. Is there a right angle in this triangle?
No.
Do you see any right angles? No, so it cannot be a right triangle. Do you see any obtuse angles? Any angles bigger? Which one's bigger, Jeremiah?
The one on the bottom.
Yeah, this one down here at the bottom is bigger than 90 degrees. So since there is an obtuse angle, then we're going to say that it's an obtuse triangle. Okay, so we're going to check obtuse. And then we're also going to classify it by the sides. What did we say an equilateral triangle was?
Oh, it was equal on all sides.
All sides are equal. Does this have 3 equal sides?
No.
No, so it can't be an equilateral triangle. Okay, we said a scalene triangle is a triangle that does not have any sides that are the same length. Do you see any sides that are the same? Yeah. The 2 that are going down diagonally are the same length. So I have 2 sides that are the same. So it's going to be an isosceles triangle. Isosceles means that 2 sides are the same. So it's an obtuse isosceles triangle. All right, right, number 4. I had a few questions about this one. We can scroll to it. Alright, so this one says Jack has 37 dimes. He saves 5 for the parking meter. He splits the rest evenly between his 4 siblings. How many dimes does each sibling get? So they've already started the equation for you and they've just left some blanks. So it told us that D represented what?
37.
Nope. What does D represent?
Dimes.
How many dimes each sibling gets? Is it the number of dimes we're starting with? No, it's the number that each sibling gets. It tells me right here in parentheses, it says D in parentheses, so that tells me that that's what that variable stands for, how many dimes each sibling will get. All right, so that's what I'm solving for. That's what our question's asking. And I've got to figure out what to fill in. I'm going to ignore my second and third row. I'm just looking at this first equation. So based on what we read, Jack has 37 dimes. What am I starting with? 37. So which one of these missing pieces is going to be 37? Which one's it going to be, Tatum?
It's gonna be A.
Yeah, A is going to be 37. Jack has 37 dimes, and he's saving 5 of them. Okay, so that tells me that I'm taking 5 of the 37 out. He splits the rest evenly. If we split something evenly, what operation are we using?
Equal division. Something like the numbers.
Yeah, division. We're going to divide them into equal groups. So they have the division symbol for us. And how many equal groups are we making? 4. So what is B going to equal? 4. All right, so we have 37 minus 5. And that's going to be divided by 4. Does anybody know what those parentheses mean? You have 37 minus 5 in parentheses.
No.
What are those parentheses for, Tatum?
Parentheses are for so you can solve in between.
Okay.
Get your answer.
Yeah, so the parentheses tell us the order that we're going to work. Those parentheses are to catch your attention. They're saying, take care of me first. So before I can divide into the 4 equal groups, I've got to take away the 5 dimes that he's saving, right? That makes sense, doesn't it? So if I do 37 minus 5, that equals
34. No.
37 minus 5, 32. So they already have the 32 written for us on the next line. This is like our next step. We wrote our equation, now we're taking care of the next step. So 32 divided by what?
4.
4. That 4 doesn't change, does it? B is still equal to 4. Okay, so then the next step in our equation is that I have to actually solve. I'm going to actually do 32 divided by 4. And if I'm going to do 32 divided by 4, I could actually split them up into 4 equal groups. Or I could think about division as being the opposite of multiplication. So I can think 4 times what number equals 32? And what will that be? 8. 4 times 8 equals 32. So C represents 8. Each sibling gets how many dimes? 8. All right, so A was equal to 37. B is equal to 4. And C is equal to 8. Each sibling gets 8 dimes. Okay, so it looked a little scary, but was that really hard once we broke it down? No. What do the parentheses tell you to do? To take care of that first. All right. We've got one more question. It says, which model best represents the answer to this problem? 4 times 2/3. So if I'm doing 4 times 2/3, we know that we can think about multiplication as repeated what? Addition. So I'm going to have 2/3 plus 2/3 plus 2/3 plus 2/3. Do you see any of those options that we can automatically eliminate?
Yes. Yeah.
Which one can we automatically eliminate, Bryce?
The first one, because it has the wrong. It's marking.
Yeah, it's taking some away, right? So we know that if we're multiplying, we're not taking anything away. So I don't even have to worry about option 1. I know option 1's out of the question. All right, so now I'm going to look at my other 3 options to see which one shows 4 groups of 2/3. So to do that, I'm going to look at each piece, and I'm going to group them together into 2/3. So if I look at option 2 here, if I group 2 of my pieces together, if I take these 2 right here and group them together, there's one group of 2/3. Okay. I know I still have one here, and that's okay. We're going to come back and get it in just a second. But I'm going to go ahead and do my 2/3 that are together. All right. If I look at this second one, here's another group or set of 2/3. That gives me 2 2/3. So now I can come back and I can take these 2 extra pieces. There's 1/3 and another 1/3. That gives me another group of 2/3. How many 2/3 was that? How many? 1, 2, and these 2 together make 3 groups of 2/3. So does that represent 4 times 2/3? No, I've got to have another group of 2/3. So knowing what we know from option 2, is it going to be option 3 or option 4?
3.
Which one's it going to be, Ainsley? It's going to be option 3. How do you know that?
Because option 3 has 3, but then 2 of them, there's still 1 more, so that's
Okay. Why is this one
because
not correct?
those 2, one of them has to be colored in. One of them.
Yeah, exactly. I'd need one more of those pieces, wouldn't I? Here's one group of 2/3, 2 groups of 2/3, 3 groups of 2/3, but then I only have 1/3 more. I don't have a whole nother set. So option 3 is the correct answer.